Hey everyone, let's study spherical coordinate systems. Okay, why do we need a spherical coordinate system now? We have our Cartesian, we have cylindrical, but spherical coordinate system is very much appropriate when we are dealing with problems that have a degree of spherical symmetry. Spherical symmetry, as in you can say where we are inside our Mother Earth, and that is almost spherical in shape. So if we have to deal something like where did the satellite go from from suppose the vertical longitude or something like that, then we can use these sort of coordinates in such a case, and it'll be pretty easy when we are using such coordinate system compared to Cartesian or cylindrical in such cases. So basically you can imagine that you are suppose sitting in the middle of the earth, maybe somewhere in Turkey. Yeah, you can check Google, wherever is the center of the earth. You're sitting there. Suppose you are sitting here, and imagine a line from the top of your head. Consider that z-axis. Okay. Then next, suppose you consider a object here. This is P, suppose. Okay, you consider an object whose position vector is P. Okay, that is at an angle theta from z-axis. Okay, that is at an angle theta from z-axis, and from the center it is at a distance r. Okay, so this theta, we call this theta as co-latitude, you can say co-latitude. Yeah, okay, whatever, you can say it's co-latitude. Okay, this theta is the angle of this of your object P, of your object which is at position vector P. Okay, at an angle from the z axis. Okay, from the vertical axis. Okay, and what is r? R is basically the distance from the origin. Okay, then next thing is phi. Phi is the same that we had seen in cylindrical coordinates, and that is the angle. That is, suppose you drop down this position vector into the xy plane, you drop it down, you get a point over here, and this from the x-axis it makes an angle theta, phi. Okay, this phi is also called azimuthal angle. Okay, azimuthal angle. This r, you can say, is the radius of this sphere. Okay, so basically when I'm saying it's the radius of the sphere, then I can say this radius can expand starting from 0 up to wherever you want, up to infinite. Suppose if you are considering the earth, then you can take the radius of the earth. If we are considering a small ball, you can consider that r is something smaller. Or if you are considering the entire universe or more than that, then you can go up to infinity. Okay, then this is your limit for r. Okay, the next, theta. What is the range for theta? Okay, see, basically for this you need to understand that how this sphere is being created by using r, theta and phi angle. Okay, so basically suppose you're sitting in a room over here, yeah, on the center of the earth, as we discussed earlier. Suppose there's an object here. Okay, and this is at an angle theta. Okay, from wherever you are. Okay, then if I suppose make a circle over here. Okay, I make a circle over here. Okay, let me simplify it here over here. Suppose you are sitting here. This is your vertical axis. Okay, this is z axis. From here, this I said this is r, this is theta. Suppose I made a circle over here. Okay, suppose I increased my theta now. a little further. Then I made a circle over here. Okay, let me make it 90 degree, my theta. Okay. Then I made a circle here again. And then again I increased my theta further. Further I increased it. Then I made a circle over here. Then it became smaller again. Then over here I reached. Then I made a circle over here till this point I reached. Okay. When my theta is 0, then this is point. Over here I am not making any circle. Over here I am making, if I join this, okay, I get some sort of I get a sphere. Okay, I get a sphere over here. So basically what happens over here is theta, you can vary theta from 0 degrees, up to 180 degrees, and this phi is basically the angle on the x-axis. Is basically the angle on the x-axis, and if you make a complete circle, then you can vary phi from starting from 0 degrees up to 360 degrees. Similarly, theta you vary from 0 to 180 degrees. Okay, you vary it up to 180 degrees. So basically this is one sort of a limit. Okay, this is one sort of limit, but this doesn't mean that you can't make a sphere with some other sort of limits. We'll discuss that further, that how you can make a sphere by changing your limits. As in suppose if I draw half a circle. Suppose over here, instead of drawing full circle, I drew half a circle. That is I varied phi from 0 up to 180 degrees. Okay, 0 up to 180 degrees. Then, and on the other hand, I increased my theta beyond 180 degrees. That is this portion also up to say 360 degrees. I increased it from 0 to 360 degrees, and I reduced my phi from 0 to 180 degrees. Then also I can form that same sphere. So like this, you have to go on thinking that which limit is appropriate for creating the sphere you want with the limits that you can define. Okay. Anyways, so this was all about spherical coordinates. Okay. So this, we have to write the coordinates. We write it in this format: r, theta and phi. Similarly, as we had done in cylindrical coordinates, we can do it here as well. Over here also we can define a position vector. Position vector where I'll say this is something like this. Okay. And so basically these all are unit vectors in r, theta and phi direction. Okay. So this is my vector. Okay. And then what about the direction? What is the direction? Like we know in x-axis, our direction is, this is our y-axis, this is our z-axis, this is our x-axis. These are the direction. So if I have to draw a unit vector in that direction, I say this is the unit vector. So what about the directions? Where do these point to? Okay, AR cap is simple. This, you can say this is AR cap, that is along the direction of the radius. And what is A theta cap? Well, A theta cap basically you can consider a sector theta like this. If you draw a tangent to this sector, this will be your A theta cap. Okay, so basically this portion's tangent is along this direction. So this is what you can say as your A theta. Okay, and what is A phi? A phi also similarly you can go this, you consider this portion as a sector. This is your rho as you had seen in cylindrical coordinates. This is angle phi. So it'll go tangentially to this sector, so this direction. So this is represented over here as a phi cap. Okay, is that clear? Then next, after having seen the direction, you also want that you want to compare the coordinates, Cartesian coordinates, cylindrical coordinates, and spherical coordinates with each other. So how can we do that? Okay, first of all, in cylindrical coordinates, we knew we had a rho, that is x square plus y square. In this case, our r will be the sum of the square of all the three Cartesian coordinates. Okay, and what else? We have theta. Okay, we have theta. Then let's see what can theta be. See, basically this is theta. Okay, this is theta, this is r. So if suppose I consider this is my z axis, this is my rho. Rho is basically the drop down vector of position vector p on the xy plane. As you can see it over here, this is position vector p. If you drop this down onto the xy plane and join it with the origin, then that is your rho. So basically rho and z are perpendicular to each other, and r is this. Okay, and this is theta. So by seeing this, you can very easily say that theta, you can say it's tan inverse. It is tan inverse rho by z, or if you want to write it in Cartesian coordinates, then you can write it as root over of x square plus y square divided by z. Okay, and then next phi is already defined in the previous cylindrical coordinates, and that is y by x. Okay, this is defined like this. And then if you have to go reverse, as in if you have to say what is x equal to in terms of your spherical coordinates, then what can you say? X is equal to, in cylindrical you had written rho cos phi. Let me draw it over here for you. This is suppose x, this is suppose y, suppose this is xy plane only, and this is rho. Okay, and this phi is always defined from x axis. Okay, so rho cos phi, you can write rho cos phi, then and y you can write rho sin phi, as this you had written in your cylindrical coordinates. And what is rho? As you can see over here, rho is equal to r sin theta. Okay, so instead of rho, you write r sin theta cos phi. Over here also same thing you do, r sin theta you write it into, this is sin phi. And what is z? Well, z, as you can see it over here, this is your z. Z is equal to r cos theta. So let me write it over here, r cos theta. Okay, this is how you can relate both the coordinate systems. Okay, and then if you have to go in the cyclical order of directions, as you said, x, y, z go in cyclical order like this. Basically, what does this mean? If you do ax cap cross ay cap, then you'll get a z cap, and if you reverse it, you'll get a negative sign in front. Similarly, for this r, theta and phi, you go in cyclical order, ar cap cross a theta cap is equal to a phi cap. Okay, this is the order in which you'll go ahead. Okay, then next, what else do you want to take out? Well, we have to take out the vector. Okay, we have to take out the relation between a vector defined in Cartesian coordinate and a vector defined in spherical coordinate, and that we'll see in our next class. Till then, you find out what we can write. You find out what you can write the value of AR, that is the magnitude, that is the magnitude in the direction of AR cap. Okay, in terms of what? In terms of Cartesian coordinates and in terms of spherical coordinates. Okay, we will discuss all this in the next class. Okay, thank you.